Navigating the Cosmos: How 15 private satellite companies are reshaping space exploration by 2030. Introduction. The landscape of space exploration is undergoing a profound transformation driven by advancements in technology, increased investment from private sectors, and the burgeoning demand for space-based data. By 2030, the role of private satellite companies is expected to expand, dramatically reshaping how we explore and utilize outer space. This report discusses the key drivers of change, explores sustainability challenges, and outlines the evolving roles of both private and public sectors in the context of space exploration. Key drivers of change. 1. Technological advancements. Innovations in technology have drastically reduced the costs associated with launching and operating satellites. The emergence of reusable rockets such as SpaceX's Falcon 9 has revolutionized the industry, achieving a record 186 successful launches in 2022 alone. Furthermore, the miniaturization of satellites has led to the rise of smallsats and CubeSats, which now comprise about 95% of the spacecraft launched. This trend facilitates the creation of satellite constellations that offer global coverage, enabling new business models and applications. 2. Increased private sector investment. Since 2013, approximately $272 billion in private equity has been invested in the global space sector. This influx of capital has spurred innovation and competition, allowing companies like SpaceX, Blue Origin, and Relativity Space to develop cutting-edge launch vehicles and satellite technologies. The anticipated deployment of over 5,000 broadband satellites by the end of 2023 is a testament to this growth, with projections suggesting that 40,000 to 50,000 satellites could be operational by 2030, serving millions of users worldwide. 3. Rising demand for space data. The increasing reliance on satellite data across various sectors has given rise to the space data as a service market. Companies are now offering tailored satellite data services catering to applications such as agriculture, disaster response, and urban planning. This trend highlights the growing integration of space-based insights into everyday business operations. Sustainability and challenges. While the future of space exploration appears promising, it is not without challenges, particularly concerning sustainability. The accumulation of space debris poses a significant risk to ongoing and future space missions. To address this issue, various strategies are being explored, including deorbiting guidelines. Organizations like the European Space Agency and the Federal Communications Commission (FCC) have developed guidelines for disposing of satellites at the end of their operational lives. Debris removal technologies. Innovative solutions such as ground-based lasers and space tugs are being explored to remove existing debris and prevent future accumulation. Orbital refueling. Technologies being pioneered by companies like Northrop Grumman and Orbit Fab aim to extend satellite lifespans through in-space refueling, reducing both costs and debris generation. Evolving business models. 1. Satellite constellations. The development of satellite constellations is a key trend reshaping the space market. Unlike single satellites, constellations provide global coverage, ensuring at least one satellite is available at any given time. This capability is driving demand for satellite integration and launch services. 2. Space data services. The increasing demand for space data services indicates a shift towards a subscription-based model where customers can access tailored datasets for specific applications. This trend is likely to grow as the capabilities of satellite technology expand. 3. In-space manufacturing. The potential for in-space manufacturing is gaining attention, with companies exploring the unique conditions of microgravity to produce materials that would be challenging to manufacture on Earth. Technologies like additive manufacturing, 3D printing are paving the way for this innovation, though significant challenges such as high launch costs and lack of infrastructure remain. The role of private and public sectors. 1. Private sector. Private companies are increasingly taking the lead in space exploration, driven by their ability to innovate rapidly and attract significant investment. This trend is coupled with a growing recognition from government entities of the importance of collaborating with private firms to leverage their capabilities and technologies. 2. Public sector. Government agencies continue to play a crucial role in establishing regulations, standards, and frameworks for space operations. Increased budgets for national security space investments highlight the growing importance of space capabilities for national defense and security. Conclusion. The future of space exploration is set to be profoundly influenced by the integration of innovative technologies, the expansion of private sector involvement, and a focus on sustainability. As we approach 2030, the collaborative efforts between private companies and government agencies will be crucial in addressing challenges such as space debris while maximizing the benefits of technological advancements. As the space industry evolves, the emphasis on sustainable practices, efficient resource use, and innovative business models will ensure that the advantages of space exploration are realized for generations to come. The growing space economy is not just a matter of advancing technology but also of ensuring that future explorations remain viable and beneficial to humanity as a whole. Counterintuitive information in Navigating the Cosmos: How 15 Private Satellite Companies Are Reshaping Space Exploration by 2030. 1. Costly launches versus increased accessibility. While the narrative emphasizes the decreasing costs of launches due to technological advancements, it is counterintuitive that the initial capital required for developing launch vehicles and satellites remains high. This high barrier to entry means that despite lower operational costs, new players still find it challenging to enter the market. 2. Space debris growth amid innovation. The rapid growth of satellite launches, projected to reach 40,000 to 50,000 satellites by 2030, conflicts with the concurrent emphasis on sustainability and debris mitigation. The industry's growth inherently increases the likelihood of space debris, suggesting that while private companies aim for sustainability, their actions may exacerbate the very challenges they seek to address. 3. In-space manufacturing hindered by Earth-based needs. The potential for in-space manufacturing is touted as revolutionary, yet the current reliance on launching materials from Earth remains a significant limitation. The promise of producing materials in microgravity may not materialize until the costs of launching equipment decrease dramatically, which contradicts the narrative of a swiftly advancing space manufacturing landscape. 4. Investment surge versus market stability. The substantial influx of private equity, approximately $272 billion since 2013, suggests a thriving market. Yet it raises concerns about market stability. The intense competition driven by these investments could lead to market saturation and economic instability, undermining the sustainability of these companies in the long run. 5. Private sector dominance versus public sector necessity. While the focus is on the increasing role of private companies in space exploration, the text downplays the essential role of government agencies. Despite the rise of private entities, government involvement remains crucial for regulatory frameworks, funding, and national security interests, which may contradict the narrative that private companies can independently reshape the cosmos. 6. Data demand versus oversaturation. There's a strong emphasis on the growing demand for space data, yet there's an underlying concern about the potential oversaturation of data services. As more satellites launch, the market could become flooded with data, leading to challenges in data management and analysis, which may contradict the optimistic projections of seamless integration into various sectors. 7. Reusability versus increased launch frequency. The focus on reusable rockets like SpaceX's Falcon 9 suggests a move towards sustainability. However, the expectation of increased launch frequencies to keep up with demand could negate the environmental benefits of reusability, leading to a paradox where sustainability initiatives contribute to further environmental strain. 8. Technological promises versus implementation challenges. Many technological advancements such as AI in space navigation and robotics are discussed as transformative. However, the text acknowledges that industry readiness for mass production of these technologies is still lacking, revealing a disconnect between potential and current capabilities. 9. Space sustainability versus economic viability. Initiatives like active debris removal and end-of-life disposal maneuvers are presented as crucial for sustainability. However, the economic viability of these initiatives remains uncertain as funding and technology to execute them are still in developmental stages, highlighting a gap between intentions and practical execution. 10. Emerging technologies versus traditional practices. The push for innovative technologies like edge computing and AI contrasts sharply with the industry's historical reliance on traditional practices. The transition to these emerging technologies might not be as swift or smooth as anticipated, suggesting a resistance to change within established systems. In summary, the narrative of a rapidly evolving and accessible space industry is complicated by underlying contradictions that highlight the challenges and realities facing private satellite companies as they reshape space exploration by 2030. The optimism for innovation and growth coexists with significant obstacles that must be navigated to realize the full potential of these advancements. In the report titled Navigating the Cosmos, How 15 Private Satellite Companies Are Reshaping Space Exploration by 2030, several significant elements may be overlooked. Yet they hold crucial implications for the future of space exploration and commercial satellite operations. 1. Space debris mitigation strategies. While many reports focus on the sheer number of satellites being launched, the significance of space debris and mitigation strategies is often relegated to a footnote. The accumulation of space debris presents a dire threat to satellite operations and the sustainability of space exploration. The Kessler syndrome, where the density of debris in low Earth orbit becomes so high that collisions create a cascading effect of further debris, could severely limit access to key orbits, impacting telecommunications, Earth observation, and national security operations. The report highlights various innovative approaches to manage this issue, including deorbiting guidelines. These are critical for ensuring that satellites are disposed of responsibly at the end of their operational life to minimize debris. Active debris removal technologies. Solutions such as space-based tugs and ground-based lasers are being developed to tackle existing debris. The significance here lies in the potential for these technologies to not only safeguard current operations but also to pave the way for future missions without the looming threat of collision. Understanding and advancing these strategies is significant as they could dictate the viability of long-term space operations and the sustainable growth of the burgeoning space industry. 2. Orbital refueling technologies. The emergence of orbital refueling technologies is another aspect that may not receive the attention it deserves. Companies like Northrop Grumman and OrbitFab are pioneering these technologies to extend satellite lifespans and improve cost efficiencies. Benefits of orbital refueling: by enabling satellites to be refueled in space, operators can extend the operational life of their assets, reduce the frequency of launches, and thus decrease the amount of space debris produced. This capability could transform mission planning and execution, encouraging more complex and longer duration missions. The implications of such technology are profound. They could lead to a paradigm shift in how satellite missions are designed and executed, making space operations not only more efficient but also significantly more sustainable. 3. The role of AI and edge computing in space data. As the demand for space-based data surges, the integration of advanced technologies like AI and edge computing is often underreported. The potential for AI to optimize data processing and enhance decision-making in real time is a critical development that could revolutionize how satellite data is utilized. Applications of AI, from spacecraft navigation to signal processing and scientific data analysis. AI can vastly improve operational efficiency and reduce the burden on human operators. Furthermore, edge computing could allow for real-time data processing onboard satellites, enabling immediate action based on the data collected. These advancements not only stand to enhance existing operations but also open new avenues for innovation in areas such as autonomous systems and intelligent data analysis, which are vital for the future of space exploration. 4. National security space investments. The report underscores the increasing importance of space for national security, a nuance often overlooked in discussions about commercial space ventures. With the escalating competition for space capabilities among nations, private companies are increasingly seen as vital partners in national defense strategies. Implications for private sector growth: the growing demand for space-based technologies for reconnaissance, navigation, and communication indicates that private companies can expect a surge in opportunities from military contracts and collaborations. This trend not only emphasizes the intersection of commercial and defense sectors but also highlights the strategic importance of space in global geopolitics. 5. Impact of miniaturization on satellite launches. The trend toward miniaturization of satellite technology, particularly with the rise of smallsats and CubeSats, is another critical point that warrants deeper consideration. While the cost-effectiveness of smaller satellites is often celebrated, the implications for the overall structure of the space market are profound. Market dynamics: as smallsats account for approximately 95% of spacecraft launched, their proliferation could lead to a shift in traditional satellite business models. The ability to deploy large constellations of these smaller satellites could democratize access to space data and services, making them available to a wider range of users, from small businesses to governments. This shift may also spur competition and innovation in satellite design, manufacturing, and launch services, fundamentally altering the landscape of the space industry. Conclusion: the report Navigating the Cosmos provides a comprehensive overview of the transforming landscape of space exploration through the lens of private satellite companies. However, the nuances surrounding space debris mitigation, orbital refueling, the role of AI and edge computing, national security interests, and the impact of satellite miniaturization are critical elements that should not be overlooked. Recognizing the significance of these facets will be essential for stakeholders involved in the future of space exploration as they navigate the complexities and opportunities of an increasingly crowded and competitive environment. 1. Technological advancements and miniaturization. The shift towards smaller satellites, particularly smallsats and CubeSats, has been a transformative force in the space industry. These technologies have dramatically reduced launch costs and enabled the deployment of satellite constellations which provide global coverage and more comprehensive data services. The success of reusable rocket technologies such as SpaceX's Falcon 9 exemplifies how innovation can drive efficiency and scalability in space exploration. This trend not only democratizes access to space but also fosters a competitive environment that encourages further technological breakthroughs. 2. Increasing private sector investment. The influx of private equity totaling approximately $272 billion since 2013 has catalyzed a wave of innovation in the space sector. Companies like SpaceX, Blue Origin, and Relativity Space are at the forefront of this investment surge, leading to the development of next-generation launch vehicles and satellite technologies. This financial backing is crucial for sustaining growth and allowing for ambitious projects such as the anticipated launch of thousands of broadband satellites, which will reshape how global communication services are delivered. The increasing role of private companies signifies a shift in the space landscape where traditional government-led efforts are complemented by commercial ventures. 3. Rising demand for space data. The burgeoning space data as a service market illustrates the growing reliance on satellite data across various sectors including agriculture, disaster response, and urban planning. As organizations increasingly integrate space-based insights into their operations, specialized companies are emerging to meet this demand by providing tailored data services. The anticipated growth in the volume of data generated by satellites, projected to reach over 500 exabytes by 2030, underscores the critical role that space data will play in decision-making processes and strategic planning across industries. 4. Sustainability and space debris management. The challenges posed by space debris are becoming increasingly prominent as the number of satellites in orbit continues to rise. Strategies such as deorbiting guidelines, debris removal technologies, and the development of orbital refueling systems are essential for ensuring the sustainable use of space. The potential for Kessler syndrome, where the accumulation of debris leads to a cascading effect of collisions, highlights the urgent need for proactive measures to mitigate risks associated with space operations. This focus on sustainability not only protects existing space assets but also facilitates the long-term viability of space exploration initiatives. These points reveal the multifaceted nature of the evolving space industry, characterized by rapid technological advancements, a shift towards private sector leadership, and increasing reliance on space-derived data, and an urgent imperative for sustainability in space operations. 1. The Space Race 1957 to 1975. The space race was a pivotal period during the Cold War, characterized by intense competition between the United States and the Soviet Union to achieve significant milestones in space exploration. It began with the launch of Sputnik 1 by the USSR in 1957 and culminated with the Apollo 11 moon landing in 1969, where NASA successfully sent astronauts to the lunar surface. This era saw substantial advancements in technology, including the development of rocket satellites and human spaceflight capabilities, driven by national pride and the desire for technological supremacy. The competition spurred government investments in science and engineering, leading to innovations that benefited various sectors, including telecommunications and materials science. 2. The Commercial Space Launch Act 1984. This U.S. legislation marked a significant shift in the landscape of space exploration by promoting private sector involvement in space activities. It aimed to encourage commercial space ventures by allowing private companies to launch satellites and conduct research in space. The act facilitated the growth of private companies like SpaceX, which emerged later as a major player in the space industry. This legislative change paved the way for the commercialization of space, leading to the development of new technologies and business models, as well as increased competition in the space launch market, ultimately making space more accessible and affordable. 3. The Hubble Space Telescope launch 1990. The launch of the Hubble Space Telescope marked a significant milestone in space exploration and astronomy. Developed through a collaboration between NASA and the European Space Agency, Hubble has provided unprecedented views of the universe, leading to groundbreaking discoveries about the cosmos, including the rate of expansion of the universe and the existence of exoplanets. The telescope's success demonstrated the power of advanced technology in space-based observation and data collection. Hubble's innovations have not only revolutionized our understanding of space but also stimulated the growth of related industries such as satellite manufacturing and space data analysis, exemplifying the transformative impact of space exploration on science and technology. Navigating the cosmos. Predictions for private satellite companies and space exploration by 2030. The increasing involvement of private satellite companies is set to reshape the landscape of space exploration by 2030 significantly. As technological advancements, investments, and demand for space data accelerate, we can anticipate several critical developments in the industry. 1. Proliferation of satellite constellations. By 2030, we are likely to see the deployment of 40,000 to 50,000 satellites in orbit, primarily consisting of small and miniaturized satellites. This surge will enable global coverage and connectivity, facilitating applications like high-speed internet access in remote areas. Companies like SpaceX's Starlink and Amazon's Project Kuiper are leading the charge, transforming how the world accesses information and services. 2. Enhanced space data services. The demand for space data will continue to rise, giving birth to a robust space data as a service market. Businesses across various sectors will increasingly rely on tailored satellite data for applications in agriculture, urban planning, disaster management, and environmental monitoring. By 2030, specialized companies will emerge, offering customized data solutions leveraging advanced technologies like artificial intelligence and machine learning for real-time insights. 3. Sustainable practices and space debris mitigation. As the number of satellites increases, so does the risk of space debris. By 2030, the industry will likely implement comprehensive debris management strategies. including active debris removal technologies and adherence to strict end-of-life disposal guidelines. Companies will invest in sustainable practices such as deorbiting protocols and the development of satellites designed to minimize debris creation, ensuring the long-term viability of space operations. 4. Advances in reusable rocket technology. The trend towards reusable rockets will revolutionize space travel by significantly reducing launch costs and enhancing sustainability. By 2030, reusable launch systems will become the industry standard, with companies like SpaceX Rocket Lab and Blue Origin leading the way. This shift will allow for more frequent and cost-effective launches, fostering greater participation from both private entities and governmental agencies in space exploration. 5. In-space manufacturing and resource utilization. The concept of in-space manufacturing will gain traction by 2030. Enabling the production of components and materials utilizing the unique conditions of space. Companies will explore technologies like additive manufacturing to create tools and spare parts in orbit, reducing dependency on Earth-based supply chains. This capability will also facilitate the extraction and utilization of resources from celestial bodies, paving the way for sustainable space missions. 6. Growth in public-private partnerships. As the space market matures, collaboration between private companies and government agencies will deepen. By 2030, we can expect more public-private partnerships focused on infrastructure development, research, and disaster response initiatives. These collaborations will help streamline regulatory processes and foster innovation in satellite technologies and applications. 7. Enhanced national security applications. The importance of space for national security will continue to influence investments and advancements in satellite technology. By 2030, governments will increasingly rely on private satellite data for reconnaissance, communication, and navigation, creating opportunities for private companies to provide critical services. The focus on national security will drive the development of advanced space assets and technologies. 8. Integration of artificial intelligence. Artificial intelligence will play a pivotal role in the future of space exploration. By 2030, AI will be integral to satellite operations, enabling autonomous navigation, real-time data processing, and predictive analytics. This integration will enhance mission effectiveness and reduce operational costs, making space missions more efficient. Conclusion. The landscape of space exploration is on the brink of a transformative era driven by the concerted efforts of private satellite companies. By 2030, the industry will be characterized by a proliferation of satellite sustainable practices, enhanced data services, and deeper collaboration between the public and private sectors. The focus on innovation and sustainability will be paramount, ensuring that the benefits of space exploration are maximized for generations to come. As we navigate this new frontier, the possibilities for human advancement and understanding of our universe will be limitless.